All right, welcome everybody. Welcome to Open Source Ecology's webinar. We'll be starting in a minute. All right, welcome everybody. Welcome to Open Source Ecology's webinar. We'll starting. Okay, it's 8 p.m. Welcome to Open Source Ecology's webinar series. This is our third one for 2016. If you go to the wiki, the collaborative literacy webinar page on the wiki, as you can see the agenda of the former Google Hangouts on air, the collaborative literacy webinars. The whole history of that is there. And I'm going to share my screen here so that you can follow what I'm looking at as well. Now, the purpose of the collaborative literacy webinar is to generate a much larger team of collaborators in an open source ecology project. We do a collaborative literacy webinar. We get involved in design sprints on a weekly basis now on a key projects that are alive. Now, the first webinar of the month, we went through the roadmap primarily. That was Monday, the February 29th. The March 7 last week was primarily about the distributed enterprise, the work on the 3D printer development, going over the roadmap and viral replicability criteria. This week is primarily about how do we collaborate. So we're working on a 3D printer right now, but how do we collaborate on the design front? So we're organizing an event for March 19th. One of the biggest keys to collaborative development is on open source hardware in terms of open source product development is you have to start looking at designs. So designs of products, open source product development, some of the key elements would include an open source cloud platform or a collaborative platform for doing CAD work. That's what we're going to talk about today. So we think that if we, first of all, design the Global Village construction set as a modular set of different machines, when we break things down into modules, many people can collaborate. Our goal is to create design guides for every single group of projects that we have, such as if we talk about a 3D printer, we can talk about 3D printer construction set, so that average individuals can get involved in the design process using tools that we make available. And that would include a design guide. It would include a workbench within FreeCAD, which is an open source CAD platform, where we can put in the different library parts of all the modules that we have, and people can start mixing and matching them to do various iterations, various modular designs that are scalable. Modular as a couple of the main properties. So how do we begin that? How do we begin the process? The CAD is a very big part, and with the 3D printer development, we can consider the construction set approach. So what I will do, I will paste the existing work. So for example, we can take, on a 3D printer, we can take, let me share my screen. We have a bill of materials. So first of all, you can go to the D3D development, which is the D3D is the distributive 3D printer. There's a development board here. We have a bill of materials in there, this bill of materials. So if you go to the bill of materials, you can see we have broken down all the different parts of the 3D printer by module. So I'll go into this document. This is D3D BOM. And if you want to try to find this development spreadsheet that I just got here from, you can go to, on the wiki, you can go to D3D development. That gets you to the spreadsheet, which has all the assets that we're generating so far on the 3D printer. So I just clicked on the bill of materials, BOM. That's what we're discussing right now. In terms of how that leads into open source CAD and open source library files. So if you look at the 3D printer, so this is the current iteration that we're building. It's something just as a starting point. We have broken it down. Let me get right into this document. We have broken it down very rigorously into every single part. So we actually did what it would look like if you sourced the parts yourself. In this presentation, so we're dividing things by modules, module 1 through 10 for the 3D printer. Starting with first of all, there's the frame at the very beginning. We go to the print bed, extruder slide, extruder assembly, power supply, Z motors, wiring bundle, print bed motor, controller, end stops, and that's it. So now we take every single part and we look for sources. That's our bill of materials. And in our bill of materials, we have our CAD place here, a placeholder for the CAD files. What we can do is see a lot of manufacturers, like if you talk about McMaster-Carr or Misumi or other suppliers, you can get the CAD files for a lot of these different parts. Like if you talk about various different screws or the extrusions that we use for the 3D printer, those things, like this extrusion, which is used for the frame, well, Misumi has it if you click on Misumi. But you can also get 3D CAD files in step format for most of these things. So let's see, CAD download is here. So you can do a thing like a CAD download. You got to log in. I'm just going to walk through the general overview. We go to the suppliers. So we've got our bill of materials. We go to our suppliers and start filling in, all the different parts. We can start generating CAD files, not generating, but downloading them off the internet. So once we download them, we can then manipulate them in FreeCAD. So I just installed FreeCAD 0.16 today. Not showing up, but if you, okay, here's FreeCAD 0.16. We can take the CAD files, import them into FreeCAD. Step file, for example, works, and then we can manipulate them. Like if we have the actual files for the extrusions, we can shorten them, lengthen them, manipulate them, rotate them until we end up with a frame. So that's very useful. We actually have a very technical design available if we download the file from the internet. So in principle, we should not, whenever we can, we should not be trying to draw our parts by ourselves. They're all standard commercial parts primarily, and then when we start designing custom things like various sheets, we can put the files up, but we can insert them into FreeCAD. So if you look at Wikipedia FreeCAD, it's getting to be quite a decent package. And for the collaborative activity to happen, access to an open source platform has to be there because you want everybody to collaborate. And that's why we want to use an open source package. One thing that we're going to do for the 3D printer and all the other different machines is create the workbenches within FreeCAD so that average people can design, get involved meaningfully in a design process where we develop the different modules, and those modules can be used within FreeCAD to do the design work. I'm booting up FreeCAD here to show you how it looks. Let's see, is that different window? Let me look at that window there. All right, so I'll show you my entire screen here, but FreeCAD, get started with it. You can download. Now, the thing is, because there's different versions of FreeCAD and some people might have trouble getting into FreeCAD, one of the things we're going to do is, just like what we're doing with the 3D printer, is to create a live Linux distribution. Let me change my screen here. A live Linux distribution where you download the file onto a USB stick, and you can run it off your USB stick so that anybody, whether you have a Mac or a Linux computer or a PC or Windows, you can use the exact same software. So for example, if we generate our library files within FreeCAD, those can go onto that USB stick, and people can literally drag and drop from a sidebar within FreeCAD. So I want to talk just a little bit more about the possibility in FreeCAD, the workflow. So we start with the different parts for machines like the 3D printer. Let me share my screen again. Different parts like what we're doing with the complete BOM. And this is something you can get involved in, because if you go to this file right now is shared. Anyone on the internet can find and view. So you can simply copy this file and start, or we can even do better than that. We can say anybody can edit this file. And that's something we can, sorry, did it wrong. We can open this file up for anybody to edit. So public on a web, anyone can edit. So right now, if you get into this file, which I'm going to type into the chat box there, you can edit that right now. So collaboratively, a large number of people can go into this document right here and go through all the parts and get all the CAD files together. And then we can do things like, so if you go back to the modules, like all the different modules, there's the frame. Well, if you have all those parts in your FreeCAD library, you can pretty easily go from this set of parts into a complete frame module. And you can do that for every single part. So you got all the different parts from your library that you have created, that we're all collaboratively creating. And next week, what I'll do is I'll actually show some of this in progress. This is just an introduction. So you've got the print bed, you've got all the other modules, so that at the end, you can build the entire 3D printer, which looks like, is there one of them here? Don't really have one in here. So the 3D printer, which looks like the one, if you go to our workshops page, you can see how the complete 3D printer looks. So that's the whole beast, but we're totally breaking down. It's actually got 260 parts. The unique parts count is about 160, and we're going through this rigorous detail of all the parts that are there. Now, the promise of that is that imagine that we generate the entire CAD set of parts. You know, we can do this for the Prusa i3 printer, which is what we're working with. But the real thing is that once we have some of the parts, we can, well, first of all, start modifying them within FreeCAD. So some of the important things to do within FreeCAD is learn how to, once you have those fixed parts, they're going to typically, if they're just step files or STL files, they're going to typically be dumb objects that have no parameters associated with them. That's one of the challenges of CAD. It's that whenever you transport between any two packages, you typically lose information. So you can assume that a lot of times when we import something, you know, like our this piece here, that will be just an object without any dimensions. You can't scale it. So probably a lot of times we might have to take that and actually reverse engineer it, i.e. make it an actual smart object, meaning that FreeCAD understands it, meaning you give like it actually, you can create the lengths and therefore you can scale it and so forth. But the way to do it, you'd have to literally draw it out again using this. You know, perhaps you can take the front face of it and draw it again within FreeCAD, because the trouble is all that information is lost when you import stuff, so they really become dumb objects. That's everything that you put in there. So one of the main things to learn is how do you turn these into live editable objects where all the faces could be stretched out and things like that. Things are actually parametrized at that point, meaning you can scale them, modify all the points. So if we have all of that in FreeCAD, we can have a good number of people working on it. And the goal is, with this 3D printer, we're going to reuse only a few parts, because this is a super entry-level design. One of the things that we don't like is that the bed, it moves. If you want to build large things, the bed absolutely has to be stationary. We're going to include an enclosure for the entire printer so you can keep the heat inside there and build larger things without warping. And we're actually adding bed leveling. If you look at Facebook, a recent Facebook post, if you look at that, Torbjorn in Sweden has developed the bed leveling for our specific machine. So you can take a look at that. You can see some of how that looks on the machine. So that's something we're able to actually add right now into the current machine. So you can see how there's a probe that basically takes different points on the machine. It jumps down, it dips down to measure the exact level of the platform so that you can basically, you don't have to level the bed yourself. That's one of the things we're already adding. But from here, we're going to take, essentially, if you look at the, take the slide with the extruder on it, the X slide, we're going to take a structure like that. And if we follow the modular approach, we can essentially design the entire machine around that as a basic motion unit. So we can do the gantry, the XY gantry, 2 x-axes on top with a transverse Y. But pretty much, I'd like to see that essentially one kind of module does both the X, Y, and Z motion. So that's one of the things we can do. And that's where the construction set approach becomes really useful, because then you can, for example, extend, you can extend the length of that. You can actually put a couple of these together to make a stronger version of the axis. You can design this piece, the printed piece, to be such that it accepts thicker rod, so that you can essentially scale this to any kind of size machine. And we're actually looking at doing the CNC torch table out of a similar design, where you can mount, instead of mounting the axes inside, you would mount it on the outside of a metal frame. So we're looking at a metal frame, just simple sheet. Then if you mount it outside, it'll be protected from the heat, so you can do something like a CNC torch table application. But the point is, we have to be able to get into CAD as a large community, work within it to share files openly. They're freely downloadable. Nobody has the limit that they can't access a piece of software, that a high-power piece of software. So I just want to show you some of the high-power capacities. If you Google FreeCAD videos, the good thing about FreeCAD is its extensibility. It's designed absolutely open source modular, such that, let me see if I can see some images, to the point that, well, one, you have the interface, but you can modify the interface to look to appear how you want it. I'm trying to find one example where they have actually an example of a motor for an airplane motor that's actually moving. And if you do things like kinematics, which is motion, the thing is about FreeCAD is that you can extend its power quite a bit. Let's see, so FreeCAD videos on YouTube. Yeah, I mean, there's plenty of videos that show some of the power of FreeCAD. There's one that shows a 3D engine and actually moving. So you can use Python to actually make scripts. You can interact with the software through a command line as well. But it's super extensible and all that. So that's why we want to get to use it and start creating our construction sets within FreeCAD. So that's pretty much a main point about the FreeCAD. So if we go back to, let me get my bearings here. So we go to the Collaborative Literacy webinar. I just want to make sure I cover everything. So currently with the 3D printer development, think about the potential of what happens when you create a construction set as opposed to one design. So what if you're designing module after module, modules that are scalable and modular by nature, so that you can modify. And further, if you open source that, if you use open source software, if you have all those files that are readily downloadable in a workbench or accessible through a workbench where you drag and drop, then I would like to see thousands of people get involved in a design. Like, how you can teach people how a printer works, how it's designed, and if you provide the actual engineered modules, can learn rapidly about how to build their own various variations of the 3D printer. For example, we can talk about a massive design sprint where there's literally, so we have design sprints on Fridays. If people learn how to use FreeCAD, we can talk about tens, dozens, hundreds, or possibly 1,000 people working on some design in parallel at the same time all over the world. If they have the same files, if they have the access to the Linux. And that's where the live Linux comes in. We want to create a version that's ubiquitously, you can run it on any kind of platform that you have. So right now we're starting, as I mentioned, with a 3D printer bill of materials and get to a whole library of parts and then create a workbench within FreeCAD. So that's our plan for the coming weeks. And this week we'd like to see if we can actually start along the lines of the bill of materials here. If we can complete this with, so basically all the CAD boxes here are, I mean, we have set up this document so that there's a CAD placeholder for each one of these items, so that if someone finds it or draws it and then puts it in a readable format like STEP or IGES format or STL, then we can have access to all the parts that we can then manipulate within FreeCAD. So that's a task that can be totally crowdsourced. So imagine we developed another machine and then we just break it down into all its parts. We download the CAD or access the CAD from online resources and many people working together. With that kind of an approach, you can have a large, huge number of people working in parallel. So for example, instead of one engineer getting on your SolidWorks and doing that over a week or a month of time that it would take, you can have that done within days. So once again, reducing the prototyping cycles, development cycles by factors of 10 or so. So this is, whoever sees this video, what I will do is, already there's a link within the Collaborative Literacy webinar to all the files that I'm showing here, like the 3D printer bill of materials. You can freely take that, and once we produce some of the instructionals, everyone can work on this together, if this is not already done. But you know, try it to see how it works, get familiar with FreeCAD, and start manipulating it. But we are going to generate instructionals for that. We don't have them yet right now. We're pretty much starting with FreeCAD as a major transition into that this year, so that many people can work together. And if that's the case, that value proposition is pretty significant. The fact that any average individual can actually get involved in a meaningful way. Not like where you're drawing stuff that doesn't make sense because you don't know, but if you're picking up parts that already are proper and engineered. So of course, you know, like a screw is for real. If you have a CAD file, that's a real part of the design. Now if you put a bunch of these pieces together into a model, like with this this tubing here, then you've got a realistic model. It's more than just the conceptual conceptual 3D CAD. And there's a big difference between the two. If you have anyone can draw a conceptual CAD drawing, it may or may not have anything to do with reality. If you're using parts that you've gotten from reality, then that connection to a workable design is so much closer. And that's why we want to pull off actual CAD files. And that's, you know, getting to a higher level, getting a little more rigorous or professional about it, that we're using the real technical design within all of our CAD work, down to the very tiny bolts. And you know that there's a huge difference between just a model that kind of shows it versus everything that is shown in there. Like we've seen, for example, with the Power Cube, just to give you an example, it looked great in SketchUp, but because we didn't have the actual library files, or you know, Power Cube recently, so I don't know how you know, we have the CAD 15.6 was one of the last ones. You can download our CAD. This is now, before it was, we're all working in a SketchUp primarily, but it turned out that some of the parts didn't fit and we kind of had to go to the drawing board. But once you start using real absolutely real CAD, and going beyond the SketchUp, beyond the kind of a little more that's more like consumer grade and more conceptual. But FreeCAD does have the professional capacity to do everything that you need, so that when you do design a design, then it's a real design, and it can be, it's going to work because you've got actual real drawings there. So that's the advantage. We invite everybody to take a look at this working document for this Friday. We'd like to get a little into a little more detail about actually having some of these parts. And actually, see, right now I'm not working in FreeCAD because we don't have any of these files yet, and I'd have to learn how to do much more in FreeCAD. So we're going to be generating the instructionals and the part libraries to do simple exercises that everybody can get involved in. So that's essentially the 3D CAD part. So that pretty much covers the CAD work right now. Just to back up a little bit on a 3D printer, if you talk about the workshop right now, the status is we've got, just for a little review on that, current status, we've got 8 people signed up. There's still 11 days left. We're holding it at the Kauffman Foundation in Kansas City. But yeah, so far so good. The major progress on the bed leveling, which has just happened, and the next step on this is to redesign this so it's an enclosed machine that's much more highly modular. One of the big difficulties in this, you see, like, there's a lot of little tiny screws everywhere. Things like, for example, today we're actually playing with this part here, this belt holder, but it's just, man, those little screws in there are just tough to get. And this gets the time of build that puts it up. Takes a little longer, but this is still going to be a one-day build. We found out that we were hoping that one person would be enough to do it per team, but it really takes 2 people per team to get this within like a 7-hour time of building. Outside of the talking and discussions, there's going to be about 7 hours of building, but it really will take that people work as a pair. And that's how we're designing the workshop, so that we can finish this. A lot of the stuff is done in parallel when people work as a team. But at the end, when you have all the modules completed, like I described, then it's somewhat of a linear process to put them all together. That's something that's quite linear. But we're going to go from here to an enclosed machine with much lower, significantly lower part count, and getting into the scalability, so that the next machine that we build is going to be, it's easily changeable from this kind of thing to much larger. Whereas here, it's, you more or less, it's not highly modular. You can say it is in one way, but in another way it's not really, because pretty much everything about this machine kind of works on this machine. You can't just take this one part and put it into some other machine and it actually works. It's, there's custom interfaces between most of the parts. So that pretty much, yeah, I mean, that pretty much covers the idea of the CAD. We don't have much more to go on as far as the CAD goes right now, as we're developing all of that. But so that's pretty much it for today, and maybe I can open it up to questions. Yeah. Do we have any questions from the big audience? We don't have a lot of people tonight. I guess it's a busy Monday, but people can see this on the web. Any questions from the audience? Let's see. Yeah. Okay. So in any case, we are continuing on the 3D printer in terms of hosting the first event. We're working on the CAD files as a group to get a fully accurate model in FreeCAD. Yeah, so people can follow this. If you're motivated to actually help out with substantial work on the 3D printer, the documents are there that you can actually start downloading the CAD and download FreeCAD, because we're going to be starting on that starting this Friday in the first the design sprint, where we actually do some real design work. and see where we take it from there based on who takes up the offer. Now, as far as the workshop itself, there is a good number of people, and we'll see how the workshop goes, but right now there's 6 people that are interested in replicating that to their own cities, which is pretty interesting. That's quite an outcome if it does happen. Now, once the people see in real life what that process is like, it is going to be rather intense because it is a very short time to build it in a day. I think we can absolutely do it, and that's our promise, by all means. But it does take a lot of preparation to make that happen, including things like organizing the whole, just the inventory, making sure that there's not a mess up in the parts. Like in both of our machines, there were a couple of parts that were missing, and that's kind of things you have to look out for, because that means if you don't address that, then somebody's not walking out with a working printer. So a lot of different details from preparation of the workflow, and it's a big process. I mean, in all reality, it's taking about 500 hours to prepare the first workshop. From then on, of course, it'll be much less as we lay out all the steps. And if you want to see all the assets that we're generating, you can go to the D3D development on the wiki, which I mentioned before. These are all the assets. We're working on a lot of the design is done. Like, for example, here, automatic bed leveling, number 13 was just added today. Then we have another tab here, event organization. We're talking about all the different things that you need to organize an event. So we're keeping track of that. So it's absolutely open source. So that's where we're at on the 3D printer. Getting basically the first experiment in generating a construction set within FreeCAD, namely just the parts themselves, then put into modules, and then turned into things you can readily drag and drop from within the FreeCAD menu. One other thing I want to mention about FreeCAD, it's directly linkable to GitHub. It is connected to GitHub such that you can have a repository in GitHub, and you can be downloading parts into FreeCAD. So think about this workflow. There's a large number of people working on different CAD files. They push them immediately to GitHub as soon as they're available, and that will appear within any person who's connected to that repository within their FreeCAD session. Everyone will be able to access those parts pretty much right after they're uploaded. Now that gets us very close to the cloud collaborative CAD platform. So think about a large number of people working together and everyone's inputting parts, and that machine or whatever we're designing is just coming together very rapidly. That's actually a very powerful feature of the extensibility of FreeCAD that's available. But that's just one of the things that we look forward to. We're generating those with the 3D printer. We're generating for the first time a construction set within FreeCAD, so getting really serious about the CAD part and making sure all the full drawings are in there to the full detail. And we'll probably get into, once we have all that detail, there's going to be issues with file size because, say you got the 260 parts in gory detail, there might have to be various tricks we have to do in order to simplify how parts are stored in memory, like maybe making them simpler or kind of like downgrading them, because a single screw with all the threads can take a lot of memory if not handled properly. So things like that. But yeah, we look forward to all that learning on FreeCAD, and we look forward to the design sprint on Friday where we tackle the actual construction set. And the goal, I guess, for the Friday would be that we put in at least some of the parts, and possibly the frame is a module that we can start modifying within FreeCAD. And the good part of that being we're teaching everybody, so that we're publishing these instructionals and the videos and the session. All of that is available so everybody, the whole community, can get brought along, as opposed to a lone engineer working in a CAD package by themselves. So that's always the theme: how to get everybody involved with access to the high power CAD capacity. So with this, I'm going to end for today and look forward to the Friday session on the design sprint. I will announce that within a day or two, and we'll continue going from there. So I'm going to check out here. Thank you, whoever is watching this on the internet. And we'll continue the weekly. This session is a weekly session. You can see the whole log of these on the Collaborative Literacy webinar page on the wiki. So this is a weekly happening where we're trying to get the entire OSC community to kind of get on the same page with the techniques and tools that we use, so you can study the former webinars for the topics that are included there. and go from there. So thanks a lot, everybody, and we'll talk to you soon.